Using just a few rolls of single-color filament to create gradient or even full-color prints sounds almost impossible. But with a Snapmaker U1 3D printer and full-spectrum printing, you can easily turn 4 basic colors into countless color blends. In this video, we'll break down the principles behind full-spectrum printing and guide you step by step to create your very first mixed-color project. Full-spectrum printing is a software-driven color mixing technique that alternates layers of different filaments to generate virtual mixed colors. It allows you to produce rich colors and smooth gradients even with only a few filaments loaded, far beyond what your tool head count would normally allow. At its core, full-spectrum printing relies on a classic visual principle: halftone. When different colors are arranged at a scale too small for the human eye to distinguish, our eyes blend them together into a new mixed color. Full-spectrum printing works much like traditional color printing, where cyan, magenta, yellow, and black are combined as dots of varying size and density to produce a full range of colors. When a 3D printer alternates layers of 2 different filaments, such as blue and yellow, it can virtually generate a new perceived color. As you can see from the picture, lower layer heights generally produce better color mixing results, which leads us to the first factor that affects mixed color performance: the color stack height. A color stack refers to one complete repeating unit of alternating colors. For example, if you set the printer to alternate 1 layer of blue and 1 layer of red, then 1 blue layer plus 1 red layer forms a single color stack. The human eye can resolve about 0.02 degrees, which means, at arm's length, around 60 centimeters, it can distinguish details roughly 0.2 millimeters in size. If the layer height is set to 0.2 millimeters, the resulting color stack reaches about 0.4 millimeters, making the color layers likely visible at that viewing distance. And if we cut the layer height in half, the color stack height drops to 0.2 millimeters, which becomes much harder for the eye to distinguish. Further reducing the stack height makes the layers even harder to notice, meaning that smaller layer heights produce better color mixing results. Also, when the filament is translucent, thinner layers make the colors blend more easily with the layers around them. That's because translucent materials let light travel between layers rather than absorbing it all. Some stays in the current layer, and some passes through to the next. The light that finally reflects back to the viewer becomes a mix of multiple layers, with the color difference softened and the overall contrast lowered. If you print the same model with the same settings using opaque and translucent filaments, you'll see that the translucent one produces softer color boundaries and smoother blending. So we can say that using translucent filament can noticeably improve the color mixing result. Full spectrum printing has one obvious drawback. It requires frequent color switching, both between layers and within the same layer, which is extremely time-consuming and wasteful on a typical single-head multicolor printer. But as a tool-changing printer, the U1 can switch filaments in seconds without much purging. Compared with ordinary multicolor printing, full-spectrum printing on the U1 doesn't significantly increase time or material usage, making it well-suited for this technique. Before we move on to the hands-on section, we'd also like to give a special thanks to community creator Wombly Wonders. Some of the explanations and practical tips in this video are based on his article on full-spectrum printing. We'll include the link to his original post in the video description, and we encourage you to check out his full write-up for more details. Before you start, make sure you've downloaded Snapmaker Orca V 2.3.3 or later, or updated it inside the software. To ensure a successful print and achieve better color mixing results, you'll also need to complete the bed leveling and multi-tool head offset calibration on your printer first. Now, let's pick a model and start slicing. For your first attempt, it's best to choose a model with clear color regions, simple geometry, and enough surface area. Models that are too small or have complex, tiny details may weaken the color mixing and transition effects. Import the model and make any adjustments you need. Next, we'll select 2 to 4 filaments. There are 2 basic rules. First, as mentioned earlier, use translucent filaments whenever possible. In this video, We'll be using translucent PLA in cyan, magenta, yellow, and gray. Second, choose filaments of the same material type, such as using all PLA. Avoid mixing materials with poor adhesion, which can lead to layer shifting or print failure. Update filament information in Orca either by editing it manually or by syncing it with the printer. Click the plus icon in the color mixing section to add a new mix. The software provides 4 mixing modes: ratio, cycle, match, and gradient. In ratio mode, you can drag the slider to adjust the mixing ratio between 2 colors. The lower left preview shows how the filaments will be layered during printing, while the lower right one shows the final color you can expect on the model. To mix 3 colors, click the plus icon in the upper right corner to add another filament. You can then drag the dot inside the triangle to adjust the proportions of all 3 colors. When a color's proportion becomes too low to be noticeable, it can negatively affect the final mixing result. Adjust the ratio if the software shows the warning. At the bottom of the window, Orca offers ready-to-use mixes based on all available filament colors and the number of colors you've selected, 2 or 3. Now, let's add the next color using the cycle mode. In this mode, you can freely choose the stacking order of the filaments. Click a filament number or type the sequence to add a new color layer on top of the existing stack. For example, entering 134 will repeat the cycle magenta, cyan, yellow for the selected part of the model. And in match mode, you can enter a hex color code or pick a color from the palette, and the software will calculate the closest possible mix based on all available filaments. If the result isn't quite what you want, you can tweak the mix manually. Finally, gradient mode supports blending any 2 filaments. You can choose the filaments and set the gradient direction, such as magenta to cyan or cyan to magenta, or simply pick one of the available presets. Now, we've created 3 new virtual single-color filaments and 1 gradient filament. It's time to assign the colors to the model. Right-click the model and choose Change Filament to replace the original base filament, filament 1, with any other color. To apply different colors to different parts of the model, you'll need to use the color painting tool. Select a color, choose the Fill tool, and use Ctrl plus mouse wheel to adjust the Smart Fill angle. Find an angle that covers the area you want without spilling into other regions. Then left-click to apply the color. Fill painting usually won't get everything in one go. For small details that weren't filled, you can switch to the Circle tool or Triangle tool to refine them. The next step is to set up the printing parameters. Go to Multi-Material, Color Mixing. The option Subdivide Mix Layer further subdivides the layer height specifically in mixed color regions. For example, if your overall layer height is 0.2 millimeters, enabling this option may result in a mixed layer made of 0.08 millimeters of filament A plus 0.12 millimeters of filament B. These numbers aren't fixed, as the slicer automatically adjusts the amount of each filament to match the target mixing ratio. Turning this option on usually gives you better color mixing results, but it will also increase the total print time. When Subdivide Mix Layer is enabled, you can keep the overall layer height at 0.2 millimeters. If you leave it off, you'll need to lower the layer height to 0.1 millimeters or below to avoid visible color banding in the print. However, if any of your colors include a gradient mix, this option becomes mandatory. The subdivision allows the filament ratios to shift gradually from low to high across the painted region, which is what makes the gradient effect work. Full Domain is an extension of Subdivide Mix Layer. When enabled, the sublayer subdivision applies not only to the painted mixed color areas, but to all regions that use color mixing. For example, this cube is mainly purple, blue plus red, and one of its faces has a small area painted in green, blue plus yellow. If you zoom into the slicing preview, you'll see that before enabling Full Domain, only the green painted area is subdivided, while the purple region is not. After enabling it, all mixed color regions are subdivided. If your model includes gradient colors, Full Domain has to be enabled so the gradient can be applied properly. When Apply to Infill is enabled, The infill inside mixed color regions will use the same sublayer strategy as the outer walls. This can improve the overall visual effect when using highly translucent filaments. So, if you're using opaque filaments, you can leave it off. Finally, adjust the purge volume under Multi-Material Prime Tower. A recommended value is 20 cubic millimeters. If you're already feeling a bit lost, don't worry. We've put all the recommended settings into a table you can follow. Once everything is set, slice the model, preview the toolpaths and color mixing, and start printing. If you notice the left and right sides of your print coming out in different colors, like one half green and the other half white, it means the tool heads are misaligned on the X or Y axis. Running the multi-tool head offset calibration again will fix it. Full spectrum printing still isn't precise color matching. The final look depends on many factors: base filament colors, translucency, layer height, model geometry, slicing settings, and even lighting. Orca works more like a color mixer and preview tool, showing you how the colors shift and helping you adjust in the right direction. Hopefully this video gives you a clearer picture of full spectrum printing and inspires you to explore a wider and more creative use of color. Thanks for watching!